So at this point in time, please can we put our hands together for no other person than the chairperson of this particular session, and that's the person of Engineer Godfrey Omakaru, Metering Head, Shell Petroleum Development Companies, LPDC. Please put your hands together for him as he comes to take his spot. Well, it's all right, whatever way works for you. Joining him up there at the podium is Madam Oluwa Fikayo. Please, can you come up of New Cross Exploration and Production Limited? You're going to be also speaking or presenting with the topic accounting for unaccounted for gas and gas shrinkages. All right. Then we have Engineer Bashir Umar. I'm not sure that he acknowledged when I mentioned his name. Oh, you are there. Pardon me. Okay, please put your hands together for him. Head Control Room, Rano Gas. We're looking at LPG cost study transfer measurement, lessons from terminal operations. Very important. I like lessons, they help. And of course, Tele Moses of NMDPRA is going to be talking on engendering transparent fiscal metering in the midstream and downstream gas subsector. Thank you very much. Why is the lady sitting at the edge? Please, can you come and sit near the chairman? You can help him balance well. There's an effect that always has. Thank you very much. And my very good friend and Tim Van den Hopsteen, ODS metering system, is going to be speaking on maximizing value in the downstream sector through accurate measurement. The time is just about 2 o'clock. I guess we will be able to wrap up this session and then the final session as the case is. So, Mr. Chairperson of the session moderator, we're going to be depending on you to coordinate the session. So each of them will make the presentation. Please, you have the right to let them know if they're taking too much time, and they should be conscious of the time they have to present. And afterwards, we can now have the questions, and then we wrap up the session. Online participant, we recognize you. Thank you so very much, Kamal, I think, who actually sent in a question or comment. If you have any comment or questions, please be free to reach out to us. And of course, as soon as I have my media teams, I'm going to recognize them. Thank you, ladies and gentlemen. Over to you, sir.
Right. Thank you. Good afternoon, everyone. Mr. Chairman, permit me to stand on existing protocol. In the height of the pandemic, the whole world shut down. And something struck me then. I saw crude run to $0 per barrel. But there was something about gas. The pandemic didn't know whether there was winter or not. So the demand for gas was there all over the world. And that's one thing with energy. So how did we utilize this? And that was where a whole lot of countries started thinking differently. And when we came out of that, we saw the Russia-Ukraine crisis again. And when it hit, I think it got us thinking about what we call the energy security. So there's a major contributor to this. And gas is one that is on top. I'll say that. And so for this presentation, we will be talking about fiscal measurement. And in dealing with that, so it's bringing in all stakeholders. So you have the government, like in our case, that owns our resources. You have the operators, and you have the solution providers. So this is going to be an interesting session where we have the operator, you have the regulator, and also you have the solution provider. We'll be looking at fiscal gas measurement. Even though we want to count our molecules, but do the molecules really count? When you go into the filling station to want to fill your car, sometimes, before now you can buy and then walk away. But this time around, I believe that we all try to monitor the attendants Correct. So, and this is why this session is very, very important. So we are here to learn and listen to the experts in this. So, going to the session, first, we have for the first session, for the first session, we'll be having the presentation from, you are presenting, yes. Sorry? Yes, you will be standing. So, please permit me to introduce Oluwa Fikayo, Tunde Amo. So she's from New Cross, and then she will be talking about accounting for unaccounted for gas. So, and we know we really had that in the first session. So please, a round of applause for Fikayo.
Good afternoon, everyone. It's really a privilege to be here this evening, and I quite appreciate it. Okay, so my name is Fikayo Tunde Amo. Please, do you have my presentation with you? Okay. So my name is Fikayo Tunde Amo. I work with the Crude Oil and Gas Commercial Department of New Cross Exploration and Production Limited, part of the Pan Ocean Group. My background is in accounting. I had my first degree in accounting. And presently, I'm running my doctorate of business administration. And I'm glad to be here. I hope to share my knowledge, the little that I've been able to gather during the course of this study with everyone here. Just can you open the slide? So the topic once again is unaccounted for gas and shrinkage in the gas transportation industry. And I'll be speaking generally, not just as an operator, but also as a Nigerian, because a portion of this affects the climate and it affects Nigeria as a whole. So I'll be speaking as a Nigerian.
Apologies, this little glitch getting the slide up. So why the slide is coming up? Like I said, we are all stakeholders in this. So for our nation, we all know where we are. And the revenue we derive from gas is massive, I'll say. So for the regulator, they are interested in their resources. They are interested in what we pay as royalty at the end of the day. And for the operator, they also want to maximize profit. That's good. And also for the solution provider. They also want, even providing that solution, they also want to maximize profit. So what this will help us do, please prepare your question, like we know. We'll have 20 minutes for this presentation, each one. And we'll pause for questions after each presentation. Yes. All right, so do we have the slides now? Okay, very good.
Okay, so while they get the slides on, let me just corroborate what my brother here had said earlier on monetizing, getting value for gas. And when he was speaking about it, he reminded me of COVID actually. And during that time, my company enjoyed, I'm not speaking here as my company in any way, so I don't want to be quoted anywhere. My company enjoyed the value from gas. And it was as if it was basically gas that was paying the bills. And in fact, I think we got more from gas at that period, more than we got oil. Okay, thank you. So we are back. Okay, next slide, please. Next. So as a way of introduction, unaccounted for gas and shrinkage in gas transportation is gaining the desired attention as the gas transportation network grows and more producers and off-takers get connected. Nigeria's economy has long been supported by the oil and gas sector. We can all attest to that. We generate significant income and numerous job opportunities. It is principally caused by the ubiquitous practice and gas venting and shrinkage in the oil and gas industry, a critical issue with serious repercussions. The repercussions is not faced by just those at the Niger Delta as a result of gas venting alone. Even as Nigerians, we are feeling the heat. There's a part in the slide that shows the value chain and how this UFG affects everyone in the industry. Unaccounted for gas volume is among the biggest problems that Nigerian enterprise that transports and distributes natural gas must deal with to bring to as low as possible level. Gas leaks result in gas losses, which harm the environment. Pipeline gas inventory counts that are erroneous. And 3, significant financial losses for parties, including gas producers, pipeline operators, shippers, marketers, and distributors, amongst others. I'm sure all these parties are well represented here today. So this is about we as Nigerians. It is quintessential to examine the issues that oil and gas network face, industry viewpoints, and the significance of stakeholders and community collaboration to show the viability of UFG reduction measures through successful case studies. So I'll go to what is UFG, what is unaccounted for gas. What is it? So is the portion of gas, is the difference between the portion of gas, the measured volume of gas that you inject into a facility and what you get, the delivery point. What's the difference between both? What makes that difference? What makes up that difference? Unaccounted for gas is the cumulative difference expressed as a percentage of the cumulative metered quantities of gas entering the transport system at the receipt point between the metered quantities of gas entering the transport system at the receipt point and the metered quantities of gas leaving the transport system at the delivery point. The portion of gas that leaves, that is unaccounted for, that you cannot account for. You cannot say this is where this gas has gone into. It is gas that has been lost or not been recorded. So there are 3 different perspectives to this definition here. It is gas that has been lost or not been recorded as having left the system. This includes gas lost during the leaks, gas vented during system operation, thefts, operational usage of gas, metering faults, data transfer errors, database system problems, and any inconsistencies in the billing technique. We'll be focusing more on the metering part and the losses generally, because it looked like the losses account for a bigger portion of the unaccounted for gas, according to a study that I found out. It symbolizes the discrepancies between the total volume of gas purchased by a gas utility or distributor and the volume of gas invoiced to and paid for by consumers. It could be shrinkage, own use or operational use, pilferage, administrative or billing oversight. So, unaccounted for gas is a general problem that we experience in the gas industry. Let me just segregate that. In the gas industry, I know that the network code has made provisions for shrinkage gas, but then shrinkage gas has been made provisions for. But what about the volume of the gas that you cannot even measure, that you can't even measure the quantity that has left the system? How do you account for that? Who bears the cost? Who bears that loss? Is it the producer? Is it the transporter? Is it the end user? Is it the off-taker? It's shared across board. So it's not a matter of the transporter that bears it. So I'll be speaking, if I speak as a producer, I would say that it should be borne by the transporter, because I have a battery limit and you're taking custody at that point. So whatever happens at that end has moved to them. But at the same time, I'm also a consumer. I'm also consuming this gas at the end via energy consumption. If the transporter bears this loss, somehow they would account for it. Sorry, they would monetize it. They would put a value on it, and somehow I'm going to get the eats also, and you're also going to get the eats. So what is the basis for these unaccounted for gas losses? What are the basis for this loss? What's account for this loss? Inaccurate or inadequate metering system. And let me also add the standardization of the metering system. It's not just enough for us to have an adequate metering system, but it has to be a standard going by the regulators' guidelines and policies. Gas venting. A lot of the times, there are venting that happen at the facilities, which account for this gas. There's no way they can put a measurement to this gas that is being vented. So in a way, it is unaccounted for. The pipeline typology. What is the type of the pipeline that is there? Is it on ground? Is it underground? External factors. At the point when I was doing this write-off, I was going to remove this. But then, the environmental factor can affect the loss on the pipeline. If you have a host community that is hostile, it would affect the losses, and it would affect more leakages on the pipeline. Procedural changes. How is the mass balancing being done? As long as there is human interference in a process, there is bound to be error. So what's the error that we think would happen, that we think would come up through these procedures that is being used for mass balancing? Next slide. What does gas loss mean in context? We are saying gas loss, the volume that is lost, the percentage that is. What does this even mean in context? So during my course of research, I found out that, so I'll go to the second statement. It's a bit more interesting at that end. So the second part says the gas flow measurements, they account for 81.64% according to this study. It says that, according to GRI, that 81.64% of UFG is attributed to measurement error. So that means if you get it right at the measurement level, we probably would have a lower volume of unaccounted for gas. With the remainder split between leakage, 8.85%, theft, 6.54%, and accounting. Accounting here is speaking to the volume of unaccounted for gas that you can lay claim on, which is 2.97%. That is according to journals.sagepub.com in 2019. In 2019. 2019 was just how many years ago? So this statement is still very valid. So if you are able to measure this volume accurately, then that means we are going a long way in at least getting out of this unaccounted for gas, and you can as well make a good deal of the accounted for gas. Okay, so what's the impact of gas venting on this gas loss on the environment? What's the impact? So I came about this, and I don't know, maybe I should ask the regulators, maybe at later points, because I have questions on this statement. So you're saying that you want the elimination of fugitive emission to be eliminated by 60% come 2030. So what happens to the rest of the 40%? What happens to the rest of the 40%? Are we saying that we want this to be eliminated in stages, or we feel that this cannot be totally eliminated? It's a journey. It's a journey, okay. Okay, it's a journey. I get that. And I hope someone has accepted that answer, that it is a journey. Okay, so this, I'm just trying to explain to us here that unaccounted for gas is not a problem of the producer or the transporter alone. It is the problem of Nigerians, of you and I. Like I explained earlier, you can say I'm not a gas producer, so I'm not losing any gas. You can say I'm not a gas transporter, I'm not losing gas. But you are a consumer. You are consuming gas, so you are losing money. You are losing money at some point. I produce gas and I sell to my off-takers, and the off-take is through ELPS. And NGIC is telling me that they have lost a certain percentage of this gas to unallocated, to unaccounted for gas. Excuse me. These people will not take this loss and bear it. It will be transferred to some people. If it's not transferred to the off-taker, it will be transferred to the consumer. So in a way, we are all being affected by unaccounted for gas. So I think someone should be thinking, so as a Nigerian, what can I do? As a Nigerian, what can I do to eliminate unaccounted for gas, even though the regulator has said it's going to be in phases? So what do I do? What's my contribution? What am I contributing to this? I think we should think about that. Next slide. What's the impact of UFG on Nigerian economy? What's the impact on the economy of Nigeria? Unaccounted for gas, often referred to as non-revenue gas. It's a non-revenue gas. Someone is losing money. Whether the consumer is losing money or the transporter is losing money, someone is losing money at one point or the other. Unaccounted for gas can have a variety of adverse effects on natural gas utilities, consumers, and the environment. Depending on the level of UFG and the particulars of a gas distribution system. The intensity of this effect varies. At some points, everyone is being affected, but it varies. Natural gas utilities experience revenue loss as a result of UFG because of loss or unaccounted for gas constitute a cost to the business without matching income from consumer. You are just paying for gas that you don't even know where it's going. It might even be theft. Someone is taking value for it and you are getting the it. UFG creates financial losses for utilities, which might result in increased gas price for consumer. And higher energy costs for consumers also. Also, high levels of UFG can harm a gas utilities brand, diminish consumers' confidence, and harm the public impression of the company's safety and environmental policy. I have a chart that addresses this, where I would explain all of this. Without a trace, air pollution or greenhouse gas emission are both a result of gas. Methane is the primary compound of natural gas. It is potent greenhouse gas. Methane contributes to climate change when released into the atmosphere. You are all aware of this. UFG gas leaks can endanger public safety since methane is volatile. We are all aware of this. UFG might make the gas distribution system less effective. Gas losses indicate that less gas gets to where it is supposed to. Pipelines and other infrastructures, such as equipment, can deteriorate due to ongoing gas leaks and losses. And Nigeria pays for that. Nigerian system pays for that. Unaccounted gas is a waste of precious natural resources from an energy standpoint. We are losing value. We are losing value. As a nation, as producers, we are losing value. Next slide. Okay, so this is a slide I was talking about the other time. You are losing the gas, and the gas is being emitted. It affects the climate. And we have said we are in a decade of gas. I rather said yesterday that it's no more decade of gas. We have just 6 years more. What are we doing? You're having revenue loss. As a producer, you are losing revenue. You are toiling with the shareholders' funds. You are losing the revenue. You are having governance issues. You are having litigation matters. It could lead to litigation. The host communities are not smiling about this. Thank God for the gas flare commercialization program that is going on. You are losing your reputation. If I tell my off-taker that I have sent this total volume of gas into ELPS and they refuse to get that total volume, that means it becomes an issue between me and the transporter. You begin to drag it. Oh, it's your metering system that is wrong. Oh, it's not my metering system. Oh, it's at your hand. I have delivered my gas. You're having reputational issues and insecurity. The major cause of insecurity in this nation is from our brothers. And it's not as if they really want to do it, but they are being pushed to do it one way or the other. So I hope someone is taking something back and thinking, just like I said earlier, what are we doing as Nigerians? What are we doing as Nigerians in all of this? Next. Okay, so I'll quickly run through shrinkage. Next slide, please. Next slide, please. Next, please. Okay. I've been told I have just 5 minutes more, so I'll just run through this. So what is the unaccounted for gas? I've just given this little arithmetic, this little formula. The total gas you injected less the total volume that is received at delivery point equals the gas that is unaccounted for and the shrinkage. Which one? Which one? That's what it means. There's a portion of that unaccounted for that is also shrinkage. There's a portion of it that has gone into shrinkage. But I have just 5 minutes. I have just 3 minutes left. Can you go to the previous slide, please? The previous one. Thank you. Let me just go through this, then I would be done. And I'll go to the second point. According to the Nigerian Gas Transportation Network Code, shrinkage means the gas in the system, which is used by the operator, that is the own-use gas, in connection with the operation of or which is unaccounted for as taken from the system. So there's a portion that is shrinkage, there's a portion that is unaccounted for. This portion that is unaccounted for is the main issue that we are going through in this country. It's unaccounted for. It could be leak. It could be flare. I'm not sure there's flare on this facility, but it could be flare. It could be leak. It could be theft. It could be metering inaccuracy. So what are we doing? As the operator, we are all operators, one way or the other. What are we doing about it? So please, let's go back to that my formula again. I would have loved to speak more on this shrinkage part, but I'm having too much. But I think we should please go through it and examine it again. Let me go to the recommendations. What am I recommending? We should ensure that we have accurate metering system, a standard one at that. Proper records of own-use gas, even though it will be used for your own use, for the pipeline operator's own use, it should be properly accounted for. Someone is bearing the grunt of this. We should account for shrinkage properly. Effective and efficient security surveillance so that we would eliminate gas leak or theft. We should carry out routine risk assessment. Invest in market intelligence. We have been here for about 3 days and we've had a lot of stories about technologies and all of that. What are we doing? Which one are we trying to implement? And I think the regulators should enforce it on the operators. We should ensure regulatory compliance. We are being given the liberty to operate, but at the same time, if there are penalties to some people, then I think we would work better. Then we should deploy the right technology. Thank you.
Yeah. So, thank you, Fikayo. And I believe it's an eye-opener, so again for me, based on the data. And thanks again for the presentation. Just another round of applause for Fikayo. Yeah, so we will go to the next presentation. Please, if you have your question, park it for now, note it down. And at the end of the presentations, we have opportunity to ask questions. We have enough time also to answer. Just take down your points. Our next presenter is Engineer Bashir Umar. Engineer Bashir Umar is the head control room. And for Rano Gas, he will be making his presentation is on LPG custody transfer measurement, lessons learned as from terminal operation aspects. Please, a round of applause for Engineer Bashir Umar. So we have 25 minutes for this presentation. Thanks.
All right. Good afternoon, ladies and gentlemen. My name is Bashir Umar. I work with Rano Gas, subsidiary of A Rano Group. A Rano Group is a full-stream company. We're into downstream, midstream, and currently we just acquired a marginal field. We're into upstream operations. And we also have our marine operations because we have some series of vessels running around. I don't know if my slide is ready, so I can proceed. So what I will be discussing here today is LPG custody transfer. And custody transfer basically is just the exchange of, physical exchange of product that requires some transactions between one operator to the other. Looking at the LPG terminal, okay, it's here. So like I mentioned, my name is Bashir Umar Shehu. I'm the head terminal controls for Rano Gas. So I'll be discussing custody transfer. At the LPG terminal, the two custody transfers that we have is one, we have the discharge of product from the vessels down to our terminal, and then from our terminal, dispatching into trucks, where we have some monetary activities happening. In between, we have the terminal operations, where you have gas handling, stripping, odorizing, and what have you. So we have some series of challenges which are not just peculiar to our terminal, but I believe to majorly most of the downstream gas operators in Lagos or in Nigeria at large. Because you see, vessel reception is a prominent part of our operations where you need to basically receive this product and be sure of the quantity, ship sure quantity that you received, and be able to account for that so that you don't pay the wrong monies into the wrong accounts. Next slide. Next slide. So at our vessel receipt, we had some series of challenges. But before we get to that, I would first of all entice you with the series of gadgets that we have to ensure we have accurate metering. Regardless of all of this, we were still experiencing some series of challenges, and then you will see how we're able to overcome these challenges and how they affect our operations. My presentations solely is purely technical, so I hope you enjoy it while it lasts. So, so from the vessel receipt, we have a flow meter, which is very, very important and is mandatory by NMDPRA to have that. Of course, we have it Coriolis. And what this does is it gives us the flow rate in real time of what we are receiving from the vessel. We can see the temperature of product we are receiving, density, and also it has a mass totalizer. Perfect. The second thing, as our checkpoint, which is very, very important to also NMDPRA, the vessel, and the operator, because this is the focal point of calculation. After you must have received product into your tank in any LPG terminal, whatever your flow meter says is none of the regulators of this or the seller's business. What they are important is what is inside your tank, and this, for you to know, you have to put into cognizance the temperature, pressure, and how the gas behaves in your tank. So for our system, we have some series of gadgets. We have a servo level flex at the top. We have a radar level flex just to double check the level of our liquid or the vapor in our tank. We also see the temperature and pressure of our tank in real time. It's easy, right, to know the mass of a liquid. You just multiply the volume by the density and you're able to get that. We can do that for our liquid phase because we have a calibration chart which shows the calibration of our tank, and you just multiply your volume by your density and you're happy. Okay, I know the liquid. But what about the vapor phase? Mind you, in the vapor phase of your tank, you can be having 100 metric ton. In Naira, you're talking about with gas going to 5 million today, 20 metric ton, you're talking about almost 150 million. So you can't play with that. So you need to be able to know the density of your vapor phase. In knowing the density of your vapor phase, we actually use a formula in which we have to run calculations day and night to know what's happening there. You have to take cognizance of your liquid temperature, your pressure, and your gas temperature. And then you are able now to use that into a formula to get your gas density, then you multiply by the remaining space, and you know your vapor mass. That's where the problem comes in. You would see how this formula affects our calculation and how our tank design and some operation methodologies affect these parameters to affect our system. Next slide. For the trucking out, after we receive this product, safely handled, play around with it, odorize, make sure it's safe, do our analysis, and then you are now to truck out into your trucks. We made sure we had a very automated system at our gantry levels in which we have a system where you program a key card. It's just like an ATM card. You give it down to a customer. You can see a batch controller there in blue. You just swipe the card, and the system picks the quantity the customer is supposed to load. And this whole system, we're able to input it into our control automations in the sense that the operator at the gantry has nothing to do with the card. The driver comes with his card. All the operator needs to do is to press a start button and monitor the flow as it goes. With the press of a start button, automatically our valves from the tank opens, and then our pumps starts running. We have our flow meter, we have an ROV by our gantry, and then the products start moving. We have someone 24/7 at the control room monitoring these operations, and we have terminal operators at the gantry. Everything seems okay, but then still. At our loading phase, while we are loading into truck, real time after our chemists must have taken the analysis sample of the product going into the tank, we still in the control room monitor the density of this product, real time, temperature. And thankfully in our terminal, we've been focused on refrigerated product, refrigerated cargo. If there's any downstream LPG player here, he knows how sweet that is. You want to get a cool product because you have more overage, of course. So NMDPRA are more focused. All this automation is just for our in-house checkmating. NMDPRA are more focused on the weigh bridge, right? Because the most efficient way to actually know the quantity of gas you have in a system is to weigh that system. Weigh the tire weight and then put in the gas, then weigh the gross weight. But you can't do that with a pig tank. That's why we're having so many calculations. But with a truck, we can be able to get a weigh bridge where we can take a tire weight and then the truck comes back, we take the weight of the gas. I assure you, this is the most efficient way to know what gas you have in a system, regardless of the formula you're using, regardless of your flow meter, regardless of your automation. Next. So, this is where the problem starts. In our terminals, we have so many terminals around the country with some of our biggest here in Lagos. We experience challenges with two different tank design. Why I'm bringing this up is because now we see the gas sector is going into CNG with so many people constructing a lot of gas tanks. I tell you, with every inch of pipeline going into your tank, with every dimension is taken, you have to be very, very careful and crucial with that. Because at the construction stage, someone might convince you that, you don't need to spend a lot of money. This pipe does not need to go all the way up. It does not need to go around the tank and come back. And then you see the cost is looking good and you oblige. I assure you, your operators are definitely going to suffer that because it's something that we've suffered and we are still finding ways to find solutions, even though we find some solutions to them. So for tank A, you can see when we are receiving from an LPG cargo, we received through the top of the tank. Okay. For tank A, we received through the top of our tank. The opportunity this provides is it it gives the gas an opportunity to shower into your tank. As your gas is showering, definitely you have a dead stock. And remember, you had an empty tank with a vapor going to 30 something degrees. So you want that vapor to come back to liquid because it's a huge amount of vapor. One way or the other, it has to come back. Because as you're pumping in, it's compressing, some of it has to come back to liquid. So now, if it's showering from the top, you have the opportunity to cool down this product and then make this phase change very fast, and you can be able to see the reflection of this phase change very easy. If you're receiving 2,000 metric ton, by the time you finish receiving, 30 minutes later, you're seeing your 2,000 tons in your tank because it's showering, of course. The vapor is condensing back. Now, we have a tank that we receive from the bottom in which this gas, we need a serious pressure from our vessel to actually push this gas from the bottom into this LPG tank. The problem we face with this tank is actually high temperature. And the main reason for this is just assume you're receiving a cargo at -2 degrees, LPG, -2 degrees, refrigerated cargo. And then you have a vapor phase in your tank that is around 30-something degrees. While you're pushing this very cold and chilled product up, the vapor will find it difficult to shift immediately from 30 degrees to, let's say, balance around 3 degrees or 4 degrees. Definitely, it needs time. And that time you don't have because you have a vessel waiting and demurrage is coming. You want it to move. So now, this liquid is going up, compressing your vapor phase is going up. And the implication of this is your servo gauge, your meters are at the top of your tank. And this is exactly where these high values are coming. And when the DPR man, NMDPRA guy comes, he does not want to hear anything. He wants to look at the surface of your tank, take his readings, and calculate. So how are you going to do? So it was a serious challenges and things that we're having from that tank. Tank A is fine. We have good parameters. You calculate your volume received is perfect. And well, like I mentioned earlier, you need to calculate the vapor density. The formula there at the bottom is the formula you use to calculate the vapor density. You can see the vapor temperature is a denominator. The higher that vapor temperature goes, the lower your density volume. And after receipt, the implication is your density will now be lesser. While in real sense, it is more than what you're seeing inside your tank. And now you're telling the vessel that you discharge less to me, which is going to cause a lot of protest letters back and front. So for the tank B, we experience high pumping pressure. We have to keep calling the vessel, loading master, give me 5 bar, give me 6 bar, and you're increasing the pressure. And you're stressing, sometimes they have to use booster to actually give you this product in. Second, we have high temperature, which I've mentioned is even affect our calculation, high pressure, and then we have this slow condensation rate. You might need some hours to actually know what is actually in your tank. The operational challenges that we faced were the discharge quantity discrepancy. After discharging product, vessel will say they discharged 5,000, and you're seeing 4,900. Nobody is going to let 100 metric ton go. It's a lot of product. And even though the NMDPRA graciously, they said we have a leverage of plus or minus 0.5. So if you're taking 5,000 metric ton, even 250 metric ton is an issue that you can resolve within you and the vessel. But if it is above that, DPR personnel, NMDPRA needs to follow the vessel, go to where they discharge, and then there's a serious dispute resolution in that regard. But our discrepancies does not usually exceed 250 metric ton, but I tell you 100 metric ton is a lot. We have protest letters where you need to write protest letters. Maybe you have the vessel wait for you to finish trucking out all the product and see if the product comes back, then you pay the remaining balances. That's something you don't want in business. Can you go back to the previous slide? Hello? Previous. Thank you. No, next slide. Thank you. So we have delayed cargo received because we have a set limit by regulation. We have a set limit. You can't allow your tank temperature, even though our tanks are propane rated, you can't allow your tank temperature to go above 55 degrees. So regardless of whether or not you know what is happening in the tank, once your system shows 55 degrees, you have to suspend operation. And that brings about delayed vessel discharge operations. Next slide. So for the trucking out, because before you come to the solution we provided for the vessel receipt, for the trucking out, I'm aware, I know most of us here are aware of the Coriolis flow meter principle, and I see the gentleman here is also going to provide some solutions. So I hope you're listening to our problems so that we can have some solution regarding that. And apart from him, please, after the presentation, any other person that has something that he thinks we can find a way around all these operations, I tell you, is a major problem. Not to us alone, but the LPG downstream sector. So we have this Coriolis flow meter, is Endres and Hauser. Sorry, this one is, the gantry is Emerson, and then we have Endres at the jetty. The principle of this Coriolis flow meter is you have a sensor at the inlet, and then another sensor at the outlet, and then you have an exciter at the center. And this tube that goes through your flow meter, when your gas are passing, they usually swing. And this sensor senses how this tube swings, and that gives you your mass totalizer, so metric ton per hour, so kg per hour. But the problem is this. Normally, in normal operations, when you don't have any movement, it's stable. But when you have product going through this flow meter, there's a twist. When this Coriolis, there's a twist. So the difference between these twists is directly proportional to your mass flow that is passing through the Coriolis, as you can see from there. For your density, normally, if you have a more denser product, the frequency of the oscillation is being reduced, and that also determines the density. All of this works fine, but at a point, we started noticing without loading, you would see your flow meter reading going to 3 metric tons, 5 metric tons, 10 metric tons, and you are not loading anything. And early in the morning or at the end of the week, you have the audit and compliance come to you. You will loaded this, and then your flow meter totalizer is showing this. Where's the product? So you have to find a technical reason. You have to explain yourself. So it was a headache for me for some months before we finally understood the problem. One of the problems is this. When building an LPG or any gas system, try as much as you can not to have a long pipeline network from your storage to your dispensing point. That is a very big problem for you, and you have to battle it. But regardless, after battling a lot, we had to find a way to, once in a while, solve this problem. So we had our tank to our loading gantry is virtually about getting to 250 meters, which is a lot for product movement. So the moment you don't load for 3-4 days, and then you have your liquid, some of it changing into vapor phase, you have this vapor coming into your flow meters. And once this vapor comes into your flow meters, normally you have your center of flow and you have center of fluid. These two needs to align for you to have accurate reading. The moment you have vapor into this flow meter, maybe your drive is above 3.7, then you are in trouble. Because center of mass is going to change, and flow meter is going to shift by itself, and you have a reading. And then you explain where that product goes to. You have to. Because LPG is not like white product. You can dip in white product and have the same quantity today, come in later and have virtually almost the same quantity. LPG, you can see 2,000 metric ton now. Come later in the night, you see 2,050. 50 metric ton from where? And then you can also see 1,950. So you can't use what is in the tank to convince the auditor or whoever comes to you. You can't use it. So they only rely on the flow meters and the mass totalizers. So this is an issue, but we found a way around it. Next slide. Okay, for the vessel discharge, the solution that we're able to look at were one, after vessel discharge operation, of course, we will close our jetty manifold, the manual valve. But then our ROV that is connected to the flow meter, you leave it open for at least 24 hours. Because after receiving the product into your tanks, you must have blown your line. And then definitely you have a non-return valve. You don't have anything coming back. So in that phase, you just have a vapor phase. If you shut down your ROV, you are now restricting, if you can see, the ROV to the flow meter and the NRV, the space is not much. And then you have some liquid trapped inside your flow meter. And then now you have a vapor phase immediately after, and you close this vapor phase. Definitely there's going to a vapor will slip in, and then you have your mass flow meter moving at the jetty. That's for the flow meter. We leave it 24 hours. After 24 hours, you close it. During receipt, because we have a sprinkler system, is also something that you could look into. While we are receiving this product, and the vessel is about casting off, we have to activate our sprinkler systems. After activating it cools down this product, and then the temperature goes down, and then we have a vaster condensation rate. With this particular condensation rate, you can be able to have the actual quantity of what you have in your tank well calculated. Because this calculation is not done by you alone. You have to be there, the vessel has to be there, and NMDPRA has to be there. So you have a faster calculation and everybody is happy, business is smooth. Delayed final cargo calculations. That's actually what we achieved by sprinkling the tank. We actually delayed it before we have it stamped by NMDPRA. But now, we are looking at the bigger picture. At first, we look at these 1, 2, 3 solutions to actually keep it in control. And our operations were smooth and we're having good results. But now we are moving further. Just last month, we contacted Endres and Hauser in Germany, and we are still in talks with them. We are providing them data. What we need, because at this moment, we cannot say for that particular tank, we are going to take our discharge line back to the top of the tank. That's going to be a very, very expensive business decision. So we are not even looking at that for now. But in the future, since we are developing more tanks, we won't repeat that mistake for sure. So what we are looking at with Endres is to have a correction factor. This correction factor, looking at the different temperatures and pressures and the limits and a lot of data that we provide to them will help us determine a particular correction factor. Okay, if you receive 5,000 and you're seeing 490s, after reviewing everything, your final calculation multiplied by 0.000 this, multiplied by 1.0, the correction factor is something that we're going to achieve at a bigger picture, and we are still working on this. And I tell you, in every variances that you're having in every business environment, you can always have a way to interpolate and get a particular correction factor vis-a-vis the behavior of the system. So that's what we are trying to get. This is on the pipeline, and that's why I'm urging all the solution providers here, if you are with me, we need solution. Please provide solution. Next slide. Okay, 2 minutes. So at the gantry, what we did is, since we have vapor going into our Coriolis, luckily we have a liquid return line. In case you're loading a truck and this truck is leaking, what happens? You can't discharge a leaking truck to go out of your terminal. You can't. It will come back to you. NMDPRA will follow you. So what we do, we have to make sure we discharge all of that truck and all of the product in the leaking truck back to our tank. So we have a liquid return line. This particular liquid return line is always saturated with product. So what we normally do when we see that movement, we open that, we line up the liquid return line to supply some of this product into our discharge line. And in doing so, we realize that product helps saturate the discharge line. And then you have your flow meters perfectly aligned. And we stopped having that movement. So I think once in a while, you see the movement, but it's now part of our SOP. You just go and open the return line, it saturates, and then you stop having the reading. Maybe 1 or 3 or 5 kg moved, not a problem for the company. Secondly, we have delayed inner valve opening when we want to start trucking out, we have to make sure that the automation is ready, there is a lineup from the control room before you even open your discharge manual valve, because it gives problem also. Some vapors from the trucks will just push back. Immediately you open your inner valve, you have pressure from the truck pushing back your liquid line. Before you know, some of it is into your flow meter, and then you have an issue there. So we also took our weigh bridge as focal. That's our focal point of calculation as the NMDPRA recommended. That's our focal, but all of these are our checks. And also, we also compare a lot of data. Last slide, just the achievement results. Last slide. Okay, so at the end of the day, we had some results and some benefits from what has happened, what we have done, what we have experienced, and the lesson learned. First of all, we were able to have efficient custody transfer operations. Vessel comes, we discharge our product, no protest later, everybody is happy, business is good. Secondly, we have efficient monitoring system for our own auditing purposes. We know that this is what we received. After trucking out, this is what we have trucked out. What do we have in the tank? This is our dead stock, it's good. We also have an improved time management because time is of essence. If you have a vessel at your jetty, you don't want to play with time. The moment you exceed the period that vessel is supposed to stay, you are paying in dollars. Demurrage is on you. So it's of essence to us. So we had an efficient time management, and we had improved SOP. SOP normally is very flexible. You can change one or two things, of course, carrying the NMDPRA along. We're able to look at the SOP together with our resident NMDPRA personnel, and we're able to update all of these new operations into our existing SOP. And at the end of the day, we had increased customer satisfaction. What we say we discharge to you is what you're seeing in your truck. Most of the times, our company, if we discharge and you go to your retail stations, you see overages. So please come to us. And lastly, we had increased safety, because safety is very important. You don't want to see your tank, LPG tank, not propane. Our LPGs are above 95% butane. So you don't want to be seeing 7 bars, 8 bars in your tank. It's scary. So we were able to get that pressure down, temperature down, and then we're able to increase the safety of our terminal at large. Last slide. Thank you for your time. Thank you for listening.
Thank you, Bashi. Another interesting presentation. What I see here now, I see here unaccounted for. Yes. In liquid phase, yes. In liquid phase. So, very great presentation. So, please, another round of applause for him. So, interesting. So, next presenting, we have our regulator from NMDPRA. It's not that person than Engineer Moses Tele. So, So, all right. So, Moses Tele will be speaking from the downstream perspective on what the issues are and how this can easily be resolved between the seller per se, or the supplier and the customer. Yeah. So please, you have, because of time, you have 20 minutes for this. If you can do less than, we'll be happy. Thank you.
Thank you very much, Mr. Moderator. I really wish I can do less. That's my target. And it's joyous when especially...
Pardon me, Taylor. Forgive me. Try as much as you can to do less. Chairman, just a permission. Ladies and gentlemen, if you were going to use your third eye to look at the hall from my angle, you will see that the seats are empty. I thought we earlier on agreed that we needed to fill up the first 3 seats because it's not good for the media image. So please, can we fill up the first 3 seats before Tele, who I'm taking his time, because of now that one, you guys is going to add 20 more minutes to his time now. All right. So please, can we move forward? Let's work with Mr. Picard's line. the first 3 lines, please. Please, let's fill up the first 3 seats. Let's do this second row, please, so that we're able to do a lot of imagery and then project that. Mr. Pickard, you're okay where you are? You're okay where you are? I'm making an exception for you. Just the first 3 lines. Okay, let's leave the 2 last lines behind. Sir, can you come forward? Gentlemen, please, can you come forward? Please fill up the seats. Yes, this is more like unaccounted, according to chairman. Please, pardon, the faster you do that, the faster we can wrap up the session. Thank you, Mr. Chairman. Thank you very much. Chairman, thank you very much. Over to you, Tele.
Thank you very much, sir. It's great, especially when you are presenting to the last, because people would have said almost everything. So, and I will wish to be quiet first, and I will skip some things perhaps when questions come up, then we come back to them. By way of introduction, maybe you can take the next slides. I will not say anything much about myself, but what I will just mention is that I was employed in DPR when Mr. Chairman, actually he employed me. So that is my introduction. Next slide. And so I'm happy seated here, and I have very great experts here to help me outline, and then we are going to talk very briefly about, okay, you can just go to the next slide. So go to the next slide. Right, at the level of Africa, why it is very important to deal with unlocking gas resources is because, as far as I'm concerned, reports have it that depending on who is reporting, at least between 500 million to 700 million people lack access to clean energy, correct? So whether you're looking at the report from IEA, from World Health Organization, from United Nations, you have that very huge number coming for Africa. And for our nationally determined contributions, especially oil producers around Africa, our transition fuel or energy basis, we have said, is gas. And hence the need for us to actually look deeper and closely and unlock these gas resources by way of increasing their reserves, increasing the production and the usage for the betterment of everybody, so that we can lift out our people from that very negative impression. So the slide is out. So the data on board starts with upstream data, which I reference from the OPEC, saying that Nigeria in 2022 have to this achievement, and we are hoping that before we end the decade of gas, we would have been flaring less than 1 BCM. All right, next slide. Because we all have the slides, so we can look at the statistics. So I have put up from NMDPRA records the volumes that were exported, and just for the purpose to illustrate that these numbers are good, and let us look at the trend that we are going and the need for us to transparently and accurately measure these numbers. And because all of us are Nigerians, and these numbers could be published, we are not hiding this kind of data. Numbers from the 4 export gas terminals. So we have the NGLs, condensates. You see on the left there, the various gas export terminals and the kind of product that they export. And if you look through, my numbers show that 155.4 million barrels of gas products were exported in 2022. These were numbers that were metered, and we have proper record and accountability for all of them. We also want to actually put the record straight and correct impression when people come to say, we don't know what we are producing, we don't know what we are exporting, we don't know what we are delivering domestically, we don't know this. No, we do. But we realize that there is need for us to improve the process so that these numbers will be as near accurate as possible. Just like the lectures they've been giving us about uncertainties, about accuracy, about this and that. You can get to the next slide. The next one speaks to, next slide, please. The midstream and downstream gas value chain. And then you can look at it. This is what is familiar to most of us, but I'll take a bit of time to say the PIA have introduced for us many points by which measurement should take place, and is defined by regulation. You will see that for now we have gas processing facilities for which you could have gas processing license. We have gas export facilities where you require gas export license. Gas aggregation points, you have gas transportation points, which meters should be, gas bulk storage, or gas depots, then gas distribution, and then gas retailing. Pre-PIA, you don't have these levels of transparency and opening up of the industry for many players to come in between. So each of these processes and points provide business opportunities for people to key into. And then I've also put up there what is midstream and what is downstream gas. I was going to mention and suggest to the organizers that more of RANO, and I'll be advocating from midstream and downstream perspective. Next year, we don't want to see many Shell, we don't want to see many Total, we want to see RANO, we want to see filling station people, we want to see downstream gas people. Because they constitute the large chain, actually, of the industry subsector that impacts Nigerians. And so yesterday I was talking to somebody that that Nigerians, customers are at the mercy of what the sellers do with them. When you carry your LPG cylinder, you get there and then they tell you, oh, this is a process area, don't come near. Then they collect your 12.5 kg cylinder, they go there and they weigh it, they tell you, you don't even know the process, and they fill it for you. You say, is it filled up? They say, yes, it's complete. And they bring it for you. The woman there, me and you, we don't know what content is there. Even with the weighing balance, we are not sure that it's actually 12.5. So we want those people to be here, and all of us will unveil transparency so that everybody is satisfied. You can take the next slide. The next slide is the midstream and downstream gas pipeline network. The existing gas pipeline network and the ones under construction and the ones upcoming. And I just showed this to show us the many opportunities that are there. My director had presented how much NMDPRA is doing to ensure that there's large coverage of all of these with metering systems and with all to capture everyone in the regulatory net. Next slide. So speaking to engendering transparency in the midstream and downstream gas subsector, what are the guidelines and standards about midstream and downstream gas measurement? we deal more about upstream gas measurement, where natural gas is delivered into the pipelines. But, and somebody asked this morning whether we have regulations, whether there are standards guiding measurement in the mid and downstream. Yes, there are. And I just pointed to a few of them. First one, like my director presented at the keynote address, is that the measurement regulations. So everything is hinged on the PIA 2021. We have the Nigerian Midstream Measurement Regulations made pursuant to the Petroleum Industry Act 2021. And then we also still use the Procedural Guide for Determination of Quantity and Quality of Petroleum and Petroleum Products in Nigeria. And then under it, there's a subsection, there's a section that I quote here, the Procedural Guide for Determination of the Volume of Petroleum Products by Dynamic Flow Measurement. And then you have gas metering there. So section 1.1 to 1.20 completely discuss issues around orifice plate installation requirements, Coriolis meter requirements, installation, LNG operations, measurements in standard SI units, quality of LNG trucking required in Nigeria, fuel gas measurements, gas flare measurements, gas sampler systems, use of GCs for all measures. You have all of them and how they should be done. And then beyond this, we have also reference standards like ISO 5167 that speaks to guidelines and requirements for the measurement of flow through orifice plates. You also have, and for me, very interesting, the framers of the PIA really understand where we are going. And if you were around during the pre-conference workshop, you hear a lot about calorific value of gas as the basis for billing. And for me, I have started to think, because Dr. Kansho pointed us, in fact, I was tempted to start to say that it's like every, and when I speak, I will speak downstream. It's like even including the LPG that we buy, it means that some burn out fast than others. And I have evidence. So one day I traveled, I came back, and I asked my wife, but this gas that we just put this last week is finished. Did you cook plenty things when I'm not around? She said, no. So what happened? Or she said, okay, maybe there is some leak. I said, no, there's no leak. I think that supplier must not be Irano. Maybe it's not him. So the quality of the unaccounted. So the quality of the gas that we use affects the burning capacity, because like someone told us that that gas is nothing but energy, an energy carrier. And that is what we need from it. So we have standards here that speak to calorie, and that places some more responsibility on the regulator to update his regulations and guidelines to capture all of these things so that everyone, the person selling and the person buying, get real value for what they are buying. And then we have also the EN standard. You can skip this. We can come back to it. Get to the next slide, please. So I think you done one. Okay, so I've been speaking, and then I can repeat that in a broader perspective, fiscal metering will have to do with concepts that refer to meters for measurement of hydrocarbon for sales purpose, ownership allocation, custody transfer, determination of fee, royalty, taxes, and in accordance to the local and international laws, every other thing. Next slide. The next slide will show to us that why are we metering after all in the mid and downstream and perhaps in the whole value chain of gas. Metering should provide three key things satisfactory to the stakeholders. One, it should provide accountability, it should be done in a transparent manner, and guarantee assurance. All of this will be aimed towards accuracy, improvement, revenue, customer satisfaction, and value delivery. Next one. The next slide show us, I'm a bit faster than the people here, so I will not explain this further. It's just a mention of the various meter types that we have for measurement, not only of gas, but for petroleum products, for even crude oil and everything. So talking about the diaphragm meters of the PD type, rotary meters, turbine meters, Coriolis meters, thermal flow, mass flow meters, orifice meters, ultrasonic meters, and of course, Venturi, vortex, and magnetic meters, and every other kind of meter that is approved in regulation. All of these meters have their principles of operation. They have some do mass measurement, some do volume measurement, and some do both. Correct? Thank you. Next. So what are the challenges that we face in transparency? Why is it that measurements are not done in very transparent manner? What are the challenges around that? I just highlighted about 4, and we have, in the course of this discussion, done justice to them. So the first one, challenges about transparency in gas fiscal accounting, is issues of accountability. And we have talked a lot about that. So we say absence of efficient and transparent fiscal metering systems at each measurement point. Emphasis on each measurement point. And my sister Fikayo deal with unaccounted for gas. So when you have certain gases that there is no measurement for, and you end up doing estimation. So for example, some flare gas is not meant to be the difference between produced gas and utilized gas. Some people before the then DPR and now NUPRC mandated that all flare sites should be equipped with appropriate meters for flare measurement. Some people used to have, perhaps if they try, they measure their gas produce and then maybe utilization if they are exporting some, and then the difference between what they have produced and what they have utilized, they say that is what I have flared. That is not correct. And so we are mandating that at each of the value chains in the operations, there has to be some form of measurement so that it will guarantee accountability. Technical challenges. All right, so technical challenges, then standard measurement protocols across board are insufficient, then shortage in supply of manpower, and then we dealt with that sufficiently yesterday. Next slide. So what are the solutions? Is that dynamic regulatory environment, placing some more challenge on us, the regulator, that we are doing, my director explained, and we will continue to do more. Capacity building and continuous training. This, I feel, is one of those forums. And then we need to invest in modern metering technologies. We also need to standardize measurement protocols across board. And then, of course, automation. Next slide. You can jump this. Next one. So what are my concluding thoughts? One, the downstream sector has not paid the sufficient needed attention to quantity and quality measurement of domestic gas delivered to end users, and we need to do more about that. Revenue losses can be minimized when stakeholders imbibe the culture of openness in business. Transparency in midstream and downstream gas fiscal measurement is key to industry expansion and building confidence in the industry. Then closing up the gap of energy poverty in Africa, in Nigeria, and elsewhere is dependent on how fast the gas sector accelerates its relevance in meeting energy needs of the ever-growing population. Of the about 1.4 billion population in Africa, they are estimating that in 2030, 2040, 2050, we are going to be more than everybody. So we need to scale up our efforts in supplying energy to our people. Then ultimately, there is need for transparency in quantitative and qualitative measurement of gas processing facilities, or at gas processing facilities, at offtake depots, at retail stations, to guarantee confidence and support investment in this subsector. I thank you all for listening. Thank you.
Thank you. Thank you, Kele. Thanks so much for this presentation. The next presenter is Tim Van Houten. Tim Van Houten is from ODS, and he will be talking to us on maximizing value in the downstream sector through accurate measurement. Welcome, team. All right.
Thank you for that introduction. How are the energy levels? Is everyone still up for the last, the last speaker of today, or let's see, of this section? So, well, like you said, I'm Tim van Often from ODS Metering Systems, and I already had the pleasure to do a short introduction here a couple of hours ago. And I'm coming from the Netherlands. Our company is also based in the Netherlands. We have multiple offices, which I will show shortly, but we are a Dutch-based company. But that doesn't mean that, let's say, we do not try to involve and to invest our time, efforts, and also our practices in the Nigerian market. And to that regard, I have good news. I only have 16 slides, so I can try and I will keep it briefly. If I learned something from today and yesterday is that engineers do not know the word briefly, or they will say yes, briefly, and then they continue. And, so. Yeah. 10 minutes? Oh my God, okay. So, but for the Nigerian spirit, I wanted to show you as a, let's say, a non-native and do an attempt to greet you all. So for my Igbo friends out there, Ototoma. Yeah. Somebody whispered me already, you can only use that in the morning. But for my Urabu friends, Ikaro. Yeah, thank you. Okay. And this is the most difficult one for me. For my Awusa fans, Ejina Kwana. Do I say that right? Unaccounted for, okay. If you have any feedback, if this was wrong, please go to my mentor, the MC, because he taught me these things. So, okay, but in all seriousness, let's get to the presentation. Personally, I've been working in the oil and gas sector for about 6 years, from which approximately 5 years at ODS Metering Systems, and I'm working for the international sales team. And well, we are also exhibiting here, so if you would like to see some more information, please come to us and we will gladly talk to you about it. Please go to the next slide. Oh yeah, sorry, one more back. So like I said, we have a few facilities. The main office is in the Netherlands, and we also have a facility in Belgium. We have a facility in Dubai, in Saudi, in Brazil, and in Singapore. All right. So a very, very short introduction on ODS Metering Systems. We are an independent fiscal metering system supplier, which basically means that we do not fabricate the flow meter or the instrument ourselves, but we are free to choose, select, and compile the right instruments for a system without having, let's say, an agenda to push our own brand into the system. So in that way, we are able to ensure that the technical solution that we are proposing, let's say, doesn't have any additional commercial thoughts by pushing our own products behind it. So we have been delivering fiscal metering systems since about the 1990s. And we have been delivering, which I also said today, to Nigeria for about 20 years. And as mentioned earlier, we are at this moment actually fabricating a very big, actually multiple metering systems in Lagos. All right, so looking at the theme of this year, I also had a look at the separate subdivisions that I could choose from. Yeah, sorry, please remain at this slide. Thank you, yes, I know you're eager. So, yeah, maximizing the value in the up and downstream sector through accurate measurement is the one that I've chosen. And I want to highlight, or actually pique your interest about how you can do that by using an asset management system or a software tool, let's say, that can assist with daily operations, but also with a lot more. Okay, you can go to the next slide. Okay, so in order to unlock, let's say, the gas resources and optimizing metering processes, we need to have an accurate measurement. So the first thing that we need to do is that we ensure that the metering systems that we are installing, that are operational, that they are accurate. Now, how do you do that? First of all, you need an optimized design, because if the application is not a right fit for the metering system, then it's not going to work, or at least it's going to work poorly. Secondly, once you have the system installed in the field, you need to have continuous verification of the instrument to prove that they are still working and operating how they should. And lastly, you need to have correct operational, troubleshooting and maintenance procedures in place, because if you are not properly maintaining and operating the systems, then you are also going to introduce a lot of potential mismeasurements. Next slide, please. So if we look at the total life cycle of a metering system, a physical metering system, then there are multiple phases where you can have, let's say, that have a factor in being an impact to the measurement uncertainty, to the accuracy. So if we look at the design, for example, yesterday actually, I don't remember who said it, but it was the word was used that we as physical metering systems, we are working and operating in a regulatory framework, and we are all here just to follow rules. And it sounds a bit, let's say, odd to put it like that, but it's completely true, because when we are designing a system, there are, of course, international guidelines and regulations that we have to follow. For example, the API guidelines, the AGA guidelines, ISO guidelines, and we have, of course, local regulatory departments that also put these guidelines as, let's say, compulsory. So once we are designing a system, we follow these guidelines and these regulations. Then secondly, during the fabrication, it's also very important to perform dimensional verifications. To give you an example, for example, an orifice metering system, the upstream section, that's also a very important part in the fabrication process to accurately measure the dimensions of the upstream section and the internal roundness, and there are a lot of factors that can impact your gas measurement in that case. Another example, but this is for a crude metering system, for example, is that if we have a bidirectional sphere prover, when we are fabricating a bidirectional sphere prover, the roundness inside the piping is also very, very important, because I don't know if you all know bidirectional sphere prover, but it is a very big ball sphere that is pushing liquid from switch to switch. And if there is a way that the liquid can escape over or from the ball, then that has a huge impact on your calibration. And if you incorrectly calibrate, then the meter is not going to function well, because then you are setting it to a standard that's incorrect. Once we, let's say, followed all these regulations and guidelines, we of course follow international benchmarks when we are performing the calibration of the instruments and the meters. And when a system is being installed, you also need to take into account, of course, that this is installed rightly. Because if you have, for example, a lot of loads that are going to come on the flanges of systems, for example, you can also introduce factors that impact the accuracy of the metering system. And lastly, and this is what I want to focus this presentation on, the maintenance and the operational part. Because if we look at the total life cycle of a metering system, then the biggest impact that can be achieved on accurate measurement is actually not in the initial stages, because that one is actually quite covered already. But it is in solving operational situations, correct maintenance procedures, and correct and many times, let's say, accurate verifying of your equipment. Next slide, please. Okay, so there are a few factors that we can already rule out that can potentially cause mismeasurements in the design of our systems. So if we correctly design a system, then instruments that are out of range should not be a cause of a mismeasurement. Operating parameters that are shifting outside of range should also not be a potential mismeasurement. Inadequate flow conditioning, so not enough upstream sections or swirls in your system that can cause mismeasurements, should also not be a potential mismeasurement. And lastly, fluid contaminants and installation effects. For example, a Coriolis meter is also very, let's say, if you build it in under stress, it's not going to operate correctly. So that's an example of an installation effect. Next slide, please. So, what could be potential causes of mismeasurement during operation of a fiscal metering system? No proper or in-time validations or procedures. So, for example, transmitters or instruments that are not calibrated frequently enough. Equipment failure that remains unnoticed, which is an item that is most of the times due to poor data analytics. Measurements that are out of range, faulty settings, data tampering, and equipment malfunctions. And if we draw a line, we can see that most of the impacts to the mismeasurements in an operational phase come down to human intervention. And we see that real accuracy actually lies with the user, with the operator, rather than with the equipment itself. Next slide, please. So I'm going to show a few examples of mismeasurements that are caused based on the service experience that we had, that had a quite big impact, and that could have been prevented by having, for example, an asset management system in place. And what I want to do is really, let's say, pique your interest to show what's currently the level of software packages that provide, let's say, digitalization, and how that can be used to prevent some of these examples. So, accidental data tampering. I put it in accidental because data tampering, most of the times, it's not even, let's say, based on bad intentions. It can be something as simple as a misclick. So I have an example here of an Omni, of a gas application, and I'm not sure if you can see it correctly, but you can choose, let's say, which way you want to calculate the reference density. And there are multiple options there. But if the system has been designed, for example, to be using the AGA 8 reference, and you misclick and actually use the relative density at base conditions, we have seen this, something so simple as this. We actually see that that has a 9% impact on the overall measurement already. And we are talking about systems that need to have a measurement of 0.5%, for example. So this is major, of course. Next slide, please. Also examples of poor maintenance, or untimely maintenance is probably the right word for it, where only, let's say, no preventive maintenance is being executed, but only corrective at the right, or well, not the right, at the late time. And we have a few examples of some PD meters and turbine meters, where due to improper maintenance, the meters start to give a wrong reading, and then someone starts to scratch himself behind the head, and once they take the meter out, they see it looks like this. Next slide, please. Other common examples that we see in faulting settings, for example. Bar A instead of bar G. Different ranges for transmitters. For example, a transmitter is set in the field with a range of 4 to 20 milliamps to be, for example, for a pressure transmitter, 30 to 80 bar. But then in the flow computer itself, someone didn't put the setting right, and it is a completely different range. So it is receiving the right signal, but it's translating it to a completely different value. Incorrect K-factor adjustments is also something that we see going wrong many times. So calibrations that are or not executed correctly, or if, as let's say, the putting in the data not being done correctly, and of course that has a major impact on the overall measurement uncertainty. So, next slide, please. So, what could be an option to prevent these cases? Or let's put it differently, what could be a valuable tool to prevent these cases? And right now I'm addressing, let's say, operators or owners of fiscal metering systems, because if you operate and own a metering system, then it is your responsibility to make sure that it measures as accurately as possible. So you have to ask yourself, did we do everything in our power to make sure that that's going right? And I'm glad that, let's say, the example from Mr. Victor, that's a case where it's going right. But that's, let's say, I can imagine also not without a lot of headaches to get in that process. So how can an asset management system support you in this way? So firstly, very shortly, what is an asset management system? It's a system that can be installed in a supervisory computer or in a separate server. And it is usually running on top of an existing HMI or SCADA package. And the systems, they are designed to use the information that is already available, but that's not interpreted yet, or that could have been interpreted to do a lot more. And it is also being used as a tool to let's say, prevent human errors. And and the assets in this case are, of course, all the instruments that are on the metering packages itself. Next slide, please. Yeah. So what could be one of the software tools that you can use? First of all, by having an asset management system, you can get the documentation for each and every asset. So for example, for the meter, for the transmitter, in a single clear space. This way, it's also for an operator very easy to find documents, drawings, data sheets, which is our initial, of course, in the initial troubleshooting period, because you need to know, let's say, where it was originally designed on which conditions, and that's something that you need to have readily available. We actually see many times that we are still getting questions from operators for some documents that let's say, were always delivered at the end of our projects, and that we think, how could you not have, for example, a PNID of a complete metering system if you are the operator? Next slide, please. Okay. It is possible to, for example, by using a logbook functionality, to track what data has been changed by who. And this is something that ensures security, but it is also very good if you want to trace back where an error could have started and to find, let's say, the culprit, but more importantly, to solve the issue. Next slide, please. It is also a place, or can be a place, where you have all the certificates for the calibrations in one place, easily accessible. And this makes it possible to defend your metering system. For example, when you have a discussion about the measurement values and you want to prove that your system is, let's say, very, how should I say it, is trustworthy. And you can be very transparent about that by showing that you are using instruments that are correctly calibrated and that have showing the right values. And what you can do with that, next sheet please, is that you can couple it and use it to schedule activities. So for example, we put on a few examples here for some calibrations, but if you know that you have a transmitter or a flow meter that has to be recalibrated every half year or every so many months, you can put that in the system, and then the operators, they will know and they will see in the system that they need to calibrate these instruments, and they also have, or you can add step-by-step details so that they can accurately do the, let's say, calibration without making any potential errors there. So you can actually put the operational procedures that are normally in writing in these type of systems. Now, 2 more slides. Next slide, please. And with the information that you have available, but that may not always be used, it's also possible to have a live system monitoring and to monitor the health of your system. And for example, you can also compare multiple meters to see if there are discrepancies between them. And if you see a discrepancy, then the next question, of course, is where is it coming from? And then the initial troubleshooting begins. Okay, next slide, please. So what I wanted to show is that Fiscal metering systems over the years, there isn't extreme, let's say, a lot of development. The types of measurement that are being used exist for a long time, and the manufacturers of the instrument themselves, they still develop, of course. But if we are looking at the biggest changes in fiscal metering systems, it is mostly in the digitalization and in the data acquirement and data analytics. So an asset management system could be a valuable tool to assist you in preventing these human errors, and also to have a bigger, let's say a better grip on the accuracy of your metering system, and to ensure that it is operating correctly, and also to prove and show that it is operating correctly. That is what I wanted to show you. Thank you.
And a great presentation. So we quickly go into Q&A. So before then, just by way of recap quickly, first presenter, showed us the unaccounted for, and that set the scene. So we saw that whether you are sitting here as a producer or you are a consumer, somewhere along the line, you pay for this. Yeah. So we also have presentation for unaccounted for in liquid. Yes, so another great one, and then also seeking for solution. And from the regulator perspective, bringing transparency into this, such that you don't leave your house and then you cannot account for money as well. And then lastly, we saw the bits around the solutions that we have, talking about AMS for this system. So please quickly, if you have questions, just throw in, but we'll be able to take just two just for this session so that we can manage our time. Thank you.
Okay, so we just have these two questions. How is it that the women are not answering questions? Sorry, ask a question.
Okay, so thanks and well done for the presentation. It was very inciting. My question is to you, Tim. About 2 years ago, I had an incident, a pump failure. The pump was designed to run at max 4,800 barrels per day. So that's supposed to be when one train is in service. But we had new operators that were under training. And in error, they started using the pump to feed 2 trains. And at that time, we were running at about 6,500 barrels per day. So there are mechanical ways or engineering ways to solve this problem. For example, if you put an orifice to restrict flow, max flow, 4.8, it will stop the flow. Or other E&I ways, maybe at the MCC, at a certain amperage, you tell the pump to shut down. So there are other ways, but I want to look at your system, the AMS system, overlooking my HMI. So will the AMS system be able to overlook, because this is metering also, overlook all the metering and see that a certain pump has gone above its capacity and maybe bring up an alarm or even shut down the pump instead of me losing a 50K USD pump in error? Thank you.
Good afternoon. Okay, very informative session. But my question is directed to the regulator and maybe the only lady in the crew for unaccounted gas. So for me, we're all engineers, and I believe one day we're all going to die, but the environmental impact of these hydrocarbons. So for the regulator, I don't believe finding most of these companies is like a pass for what comes into the society. We all know what happened in Port Harcourt last year. Whenever you enter, you see suits. Some days it blocks the sun off, and I don't know if you can lay more light on how you try to curtail how these unaccounted gas, especially those that are just for flaring and leakages, or how do you try to punish these companies who don't maybe follow your guidelines? Thank you.
Okay, thank you. Chairman, the last one. It says we're all engineers, we're all going to die. Some of us are not engineers, so we will live long. We won't die.
Hello, thank you so much for those who are having energy and for our, speakers. It was so wonderful. I have 3 questions, but I'm going to wrap it up fast. One is for unaccountable gas, where you said that there are factors that, these factors that, contribute to the gas being unaccounted for. And I saw the list, but there was no apportioning of percentages, maybe just a rough idea from your historic to say, this is the most, expected from what we have seen so far. We would like to know the most, high, flyer, those who actually take that. And then, Mr. Rando, you mentioned something on the fact that you use water to reduce the pressure. Are you sure some of them will not go into liquid contents? Because, when you put water, it actually take it, to liquid. So are you looking at that? And also, I hope there's no leakage of gas into, the tanks. I know you're taking care of that also. Then the last speaker, he also mentioned that sometimes this gas that we are talking about, even in the household, I'm talking about the domestic gas now. Sometimes you will, like what happened to me, but now I've learned my lesson. There will be liquid inside the cylinder, and I will assume that it's empty, and then I will go, and I will pay for 12.5. Meanwhile, the liquid content is like 30%, and they will not tell me. So I will pay for, for that and all that. And then one other scenario was when somebody was supplying gas. His customer came and said, my gas is going down so fast. What is it? And he said, we need to take account of how you're spending on gas, how you're consuming your gas. So when they went, they realized that he has bought a 2-burner gas, but he was using one before. So sometimes if you take an account of what is happening, you would know where this gas is going. Thank you.
Thank you. Thank you very much, Chairman. It's important that this question of ours will be addressed extensively. I think myself and Iman were actually having this conversation. Also in terms of issue that has to do even with safety. The fact that how do you, somebody asked that question yesterday when they asked the Emerson, how do you measure to know the quantity as the case might be? I'm not too sure whether it was Tele, was it you that asked the question, which, okay, you're even on the panel, so you can answer it yourself, all right? But I guess this is very, very important as well as we can quickly in the next 5 minutes so that we can wrap up this session. Over to you, Chairman. No, Tele, I'm not giving you permission to talk. I'm giving Chairman the authority to decide. Was there any question for him as a matter of fact?
No, yes, there was, one of the questions from the audience on how they are regulating the producers for, the pollution on the unaccounted for, to account for it. All right. So maybe we'll start with him because of the 2 questions. Yeah.
Thank you very much. I will quickly address the first question. They're asking about role of regulator, about the suit and the flare and the impact in the Niger Delta. I have also been there myself. I think the first 6 or 7 years of my career was in the Niger Delta. And like someone said yesterday during his presentation that 2021 and 2022 was our peak year of oil theft. And then there has been a lot of this illegal burning, the bonfire, and all of the other things happening there. I think, and I can be corrected, that most of this soot and environmental pollution are not as a result of gas flare from companies. Most of it is rather from illegal bunkering activities and all this oil theft. And you can be sure that the regulator does not have much role when it comes to oil theft. Okay. But we have had lots of things that we did about it, and I know also NUPRC has been collaborating with the security agencies and other. But as I said, about gas flare, yes, there's issue of gas flare payment, and NUPRC also told us yesterday what they are doing about giving flare sites to operators so that they can take the flare and use it for some other purposes to continue to bring down the flare. But I actually disagree that most of this soot and the environmental pollution is as a result of flare from legitimate operators. The second one, I think she actually provided a kind of talking about gas measurement in downstream, LPG measurement, domestic gas measurement. I was asking actually yesterday if companies, if service providers have metering solutions that can allow us meter LPGs. Of course, CNGs, they do them in the CNG plants, but for LPG, they have told us, I think one of them attempted to answer that, yes, which company was that yesterday, that Emerson, yeah, they told us that they have, even if your pipe is a quarter inch, that they can provide, I think not Corellis, Corellis solution for that. And for me, the take home for me yesterday is that from regulatory perspective, we can go back and say that not only would people be doing weighing using mass, especially for those that are having 50 kg, 100 kg, that are all of those. So it means that it's doable. But again, when I said in my intro, in part of my presentation, that we need to bring people in the core downstream so that we will realize how relevant it is for everybody to understand what is happening. The madam made illustration. If you carry 30% content to the filling gas plant to say they should fill for you, those people, they will not tell you that at least maybe God has just answered somebody's prayer that day. They will not tell you that there is content inside and therefore you should pay less than what it is. But that's the transparency we are talking about. If there is a system where someone would be able to see what is already there and what has entered, just like the weighing bridge in the depot, when the truck representative will come and then he will see the empty truck, say is 10 tons, and then when they put content for him, he see that it's 20 tons, and he do 20 minus 10, meaning that it's 10 that has entered his system. And then if Nigerians are patient enough, and if all of us build systems around allowing the customers to be part of the process, it will minimize all this 10 naira, 20 naira cheating. Thank you.
All right. Thanks, Celes. Just so, Tim, we will come to you last. The next question, she asked about the unaccounted for, if we can put numbers to the unaccounted for. So quickly, Fikayo, you can take that.
Okay, so thank you, Madam, for the question. I think somewhere along my presentation, I had mentioned that the total unaccounted for gas, that there are about 4 segments where you can allocate them into, and I mentioned that there is 81.64% that goes into metering inaccuracy or metering error. There is 8.85 that can go into leakages, theft 6.54, and the accounting path is 2.97%. And that is according to the journals.sagepub.com, so you can check that out also. Then in addition to the question you asked about the measurement on LPG, I think this question can be addressed to the NLPGA, and if you have a chance, I think they're supposed to have their next conference in Abuja, so if you have a chance, you can reach out to them for them to bring in some of these questions on board and ask at that forum that is specially designed for questions like that. Thank you.
All right, thank you. For the last question, so Tim, he has asked question around there. I believe you got a question. which he asked how it's possible for him to know what is the cause of the problem and how he can detect the issue of that pump or the flow around the metering around the system, such that it can trigger an alarm that can enable him react, or system to automatically react. So that was his question.
Yeah, so you were specifically asking with regards to an asset management system and your pump, and if there could be a way to prevent, let's say, the pump from breaking down by having it included in these systems and having alarms and preventive measures from having the pump. Yeah, okay. So when it comes to these systems, these software packages, a lot is possible. The short answer is yes. The longer answer is that you need, in order to have a good functional asset management system, you need to begin with having the right inputs. And that is going to take some time, but you need to have all the separate assets in it, and you also need to have the logic in it. And it could definitely be an option to have a pump included in it and to have alarms and additional measures added to it to prevent such a case from happening. But it all comes down to, let's say, the initial setup of such a package, and that you incorporate it from the beginning, because then it's easily possible and it can definitely save a pump. Yeah.
All right, okay. So thanks so much, everyone. So thanks for presenters and everyone in the room. So what I hear, ladies and gentlemen, what resonated with me was the unaccounted for, whether it is liquid or gas. And we as industry players, we have a key role to play in this. We have heard the problems. We have heard from the regulator. We have heard from the solution provider. And then on our own, I know that we are beginning to think about a lot of things we can do differently. So I don't expect us to be here next year and be discussing the unaccounted for gas. So we have everything we need now. So I'm sure we can shoot. So I just want to thank everyone once again for this session, and I'll say a round of applause for everyone here. Thank you.
Thank you very much, Engineer Makoro. Please, can you come up and stand quickly for a group picture? Can I have the photographer come take this up? And I want to say a big thank you to every single one of you. It's a session. I'm not too sure how I allowed the time to go beyond what, I guess perhaps it has to do with a very interesting. And we will basically, where's the photographer? Okay, good. So, where's the chairman and Dr. Sunday to please join them quickly. The next session, which is the final one for tonight, pardon me, for this evening.